Welcome to qnawire.
Here we're going to be given 50 milliliters of a 1 molar solution of sodium phosphate or sodium triphosphate, and we're given a 10 molar solution of hydrochloric acid. With this we want to prepare 100 milliliters of a buffer solution at pH equal to 12, and we're given the different pKa's for phosphoric acid, which are going to be 2.148, 7.198, and 12.375. The last one is the one that we're going to be focusing on because this is going to be the equilibrium that we're going to be dealing with. So with this, we want to know how many milliliters of HCl we should add to 50 milliliters of sodium phosphate before diluting. So in order to answer this, we're going to employ the Henderson-Hasselbalch equation, which is going to tell us that the pH is going to be equal to the pKa plus the logarithm. Let me make this plus a little bit shorter because it looks like a T, plus the logarithm of the concentration of the conjugate base. In this case, it is going to be the PO4 3- ion divided by the concentration of HPO4 that we're going to have in solution. In this case, since we're going to have the same total volume, we can rearrange this into pK plus logarithm of the amount of mole of PO4 3- over the amount of mole of HPO4 2-. For this, the equilibrium that we're going to be looking at is the reaction after adding PO4 3- plus HCl, actually the H3O plus ion generated from HCl, is going to generate HPO4 2- plus water. All of the other equilibriums, we're going to be able to neglect them because of the pH of the solution that we're going to end up with. So initially, the amount of mole initial of phosphates that we're going to have is going to be equal to the volume times the concentration, right? So this is 50 times 10 to the minus 3 times 1 molar. So we're going to have volume in liter times concentration in molarity. This would be 50 times 10 to the minus 3 liters times 1 molar, which would be 5 times 10 to the minus 2 mole. This is going to be our initial amount of mole that we're going to have of the phosphates. Let's say that we add of H2O plus a certain quantity x. So with this, the amount of change would be minus x, because this is going to be the limiting reagent, minus x plus x, and water doesn't matter. So at equilibrium, we should have n0 minus x, 0, and the x quantity that we added for H2O plus. So replacing these quantities into our Henderson-Hasselbalch equation, we're going to get that the pH is equal to pKa plus logarithm of phosphates. We're going to have n0 minus x, and of HPO4 2-, we're going to have x, regardless of the volumes that we're going to end up with. As I mentioned, this is going to be because the final volume is going to be exactly the same. So now we can replace the values. The desired pH for our solution is going to be 12. This is going to be equal to the pK, which corresponds to 12.375, plus logarithm of this quantity, n0 minus x over x. And we want to solve for the value of x. So we're going to end up with, on the left-hand side, minus 0.375. It's going to be equal to the logarithm of this quantity. Thus, 10 to the minus 0.375 is equal to n0 minus x over x. Let's solve this equation. Pass the x multiplied into the other side. Is equal to n0 minus x. We are going to pass this x to the left-hand side. So x plus x times 10 to the minus 0.375. We can factorize this. This is going to be x times 1 plus 10 to the minus 0.375. This would be equal to n0. So the final value for x would be n0 over 1 plus 10 to the minus 0.375. And this is going to be equal to the amount of mole of HCl that we added. So n0 is 5 times 10 to the minus 2 mole over this quantity. We're going to get a quantity equal to 0.03517 mole of HCl that we need to add. Here I'm rounding up to 4 significant digits. Since all of the other quantities are up to 3, I think that this should be more than enough. So with this, we can calculate the volume employing the concentration of 10 molar HCl. So the volume required is going to be equal to the amount of mole of HCl divided by the concentration, the molarity of HCl. So we're going to get 0.03517 mole of HCl over 10 mole per liter. This is going to become 3.517 times 10 to the minus, it was times 10 to the minus 2 so far, minus 1, minus 2. So divided by 10 would be times 10 to the minus 3 liters. And this in milliliters would be equal to 3.517. Or if we want to round it up to 3 significant digits, 3.52 milliliters. So this is the volume of HCl that we need to add, of 10 molar HCl that we need to add to prepare the buffer. And with that, it would be all. Thank you very much and have a good one.